Hello ladies and gents, I'm going to discuss three problems from 14D and 14E related to double angle formula in here. So let's have a look at our first one. Just proving the left hand side is equal to the right hand side, in this case sine over sine. Now you can clearly see the tan has now converted into sine. So how do we actually write or rewrite tans in terms of sine? Well, the only way that we could do is basically to write sine u on cos u instead of tan u, and likewise for the rest. So let's keep writing them. Now what can I do here? This is the left hand side. On the left hand side I have this particular expression. Now what I'm going to do is I'm going to make the common denominator in each of the numerator and denominator separately. What is the common denominator for the numerator? Well, that's cos u times cos v. So simply what we can do is I'm going to write cos u cos v as the denominator. Then what I get is I had sine u. Instead of sine u, I would have sine u times cos v. Simply multiplying these terms, just cross multiplication. And then for the other part, I would have sine v times cos u. So you can see I have taken cos u and cos v as the denominator. What I'm going to do is I'm going to draw the longer division called the vinculum. Underneath, in the denominator, again I'm going to take the cos u and cos v as the common denominator, product of these two, as I did for the numerator. What do I get for the numerator of that part? In the denominator, I had sine u. Now sine u becomes sine u times cos v. When you cross multiply these two, just in here, then I get plus, not plus, it's minus sine v and cos u. Well, using the double angle formulas, you know what to write for each of the numerators in these two fractions parts in the bigger fraction, but beforehand you can cancel these two. The denominators get cancelled. Ended up with sine u cos v plus sine v cos u. What is that? It's sine v plus u, or you can say u plus v. Either way, doesn't matter. And here underneath I have sine u cos v, the order matters here, minus sine v cos u. So if I had sine u cos v, sine v cos u, it is sine u minus v. Well, we have achieved that now, ladies and gents. Let's move on to the next one. Well, this is a little tricky one. Well, you could try this in many different ways, but for me, I think a little bit ahead. Now, if I think a little bit ahead, you can see the bracket underneath here, which is the denominator. If I multiply that with the other side, it's a perfect square. Sine theta minus cos theta square. It's a full completed square there. So that's what we get. Thinking that in mind, or just keeping that in mind, I can think of, okay, how would I get a perfect square, or rather full completed square for that one? Can I write down that as a full square? Well, the square should be sine theta minus cos theta. Well, it gives me a bit of a insight here. I have sine 2 theta. If I have sine 2 theta, I have to convert this one into a single theta form. How would I do that? Well, sine 2 theta can be written as 2 sine theta cos theta. Well, this looks like, ladies and gents, like AB, isn't it? 2AB. Does that ring a bell now to you? That's minus in the front, negative 2AB. So what do I need? Well, I need, in order for me to have A minus B square form, if A was sine theta, B was cos theta, well, I need A squared in the front, which means I need sine squared in the front. And then on the back, I should put B squared, which is cos squared theta. Well, can I get that one using 1? Can you think of? Yes, you are right. What is 1? I know the 1 is in fact, by Pythagorean identity, cos squared theta plus sine squared theta, which can be even written as sine squared theta plus cos squared theta. I know that, the one that I've written in pink. Therefore, I can simply write down 1 as sine squared theta. I should write down sine first, and plus cos squared theta. Now you can see I have bypassed one step here, where writing sine squared theta plus cos squared theta together and then split across the quantity in the middle. But anyway, you get the idea. Now division, divided by, this is my left hand side. Now I'm working at left hand side now. Sine theta minus cos theta. Now what do I get, ladies and gents, onto the numerator? Well, it looks like A squared minus 2AB plus B squared. Therefore, it should be sine theta minus cos theta squared divided by sine theta minus cos theta. Well, that will give me what? That cancels. The answer is sine theta minus cos theta, which is my right hand side. You can see that just in there. Righty. That's where the solution ends. Let's move on to another question. How to write this form into A sine x plus alpha, or case cos, doesn't matter, it could be A cos x plus alpha form. I need to find what is alpha, what is A. So how do I do this? We are going to pull the coefficients in front of each of these quantities, sine x and cos x, 1 and root 3. So you square the 1 and you square the root 3 and get the square root of that one outside the bracket. Well, what do I do this? Look, if I had A and a B form, let's say A sine x plus B cos x form, I can pull these A and a B onto a right angle triangle, doesn't matter the length, and then form the diagonal as A squared plus B squared, where I can indicate if this was theta, I can write down sine theta is A on A squared plus B squared, cos theta is B on A squared plus B squared, likewise. So I can simply convert these values using the Pythagoras theorem into a more trigonometric ratio form. That's what I do, because I need that one in order to form my equation in the form of sine x plus alpha. Now I pull that out, which is in fact 2. Root 3 squared is 3 plus 1 is 4. 4 squared is 2. So if I pull the 2 out, I should get 1 on 2 sine x minus root 3 on 2 cos x. Well, what I can do now, I can say, okay, half, I can either write this in terms of cos or sine. I'm going to pick maybe cos. So if I picked cos, what happens? I'm going to define cos alpha is half. if cos alpha is half, what is sine alpha? Sine alpha should be root 3 on 2 based on that triangle. We'll have a look at here. That will be root 3, that will be 1, that will be 2 now. I'm looking at cos alpha is half, which means my alpha is just here. Then sine alpha is opposite over hypotenuse, root 3 on 2. So sine alpha is root 3 on 2, rather root 3 on 2 is sine alpha. Therefore, this is cos alpha and this is sine alpha. And I have sine x minus cos x there. So is equal to -1. I can do few things here. When I proceed, I can in fact multiply whole equation by -1 to rearrange, or I can simply work here as I just normally work. Here I have sin x cos alpha, the way that I read, just listen, sin x cos alpha, then minus cos x sin alpha. What does that mean? Sin x cos alpha minus cos x sin alpha. Sin x minus alpha. So you could have written this one in that order, but doesn't matter. You can, if you can read it, you can easily do the answer. And there's a number 2 in the front, so I get 2 sin x minus alpha equals -1, where here sin alpha is root 3 on 2, or cos alpha equals half, or rather you can say alpha equals cos inverse half. Now I'm going to solve this one. Sin x minus alpha is equal to -1 on 2. Now tell me the angle that gives me cos alpha equals half. So what alpha I should use? What is the value, the acute angle alpha that gives me cos value to be equal to half? What is that? Yeah, pi on 3, 60 degrees. Cos 60 is half. Therefore, I can simply write here sin x instead of alpha minus pi on 3 equals -half. I am solving this equation. In general, you can solve this one. Let's say first few answers that we get for this. Let's look at first half. Sin something equals half. Sin theta equals half. What value for theta that gives me half? Well, theta equals pi on 6. Then what gives me -half? Okay, for what sine value I get -half? Well, if it is pi on 6, this should be on the third quadrant, the very first one, and then the next one is the fourth quadrant. The height is negative. The other one will be pi plus pi on 6. So the pi plus pi on 6 would be my very first answer in this equation. Therefore, I can write down, okay, x minus pi on 3 is equal to, first one is pi plus pi on 6. What is the next one? You go to the fourth quadrant, 2 pi minus pi on 6. 2 pi minus pi on 6. Now I got two solutions between 0 to 2 pi. You can in fact go backward. In this case, backward mean clockwise when you go on the unit circle. Or rather, you can go up to 4 pi likewise. You can find all the solutions between -2 pi, 4 pi, whichever interval that is being given in the problem. Now let's solve only for these two, and then we can extend the rest later. This is not for x, it is for x minus pi on 3, because this was my theta. Theta has to be pi plus pi on 6 or 2 pi minus pi on 6. Now we simplify those quite quickly. That is 7 pi on 6, and this becomes 11 pi on 6. And what I'm going to do is now simple arithmetics. You add pi on 3 to the both sides. That gives me the value for our x. So you get 7 pi on 6 plus pi on 3. And the next one is 11 pi on 6 plus pi on 3. Pi on 3 is in fact 2 pi on 6. Therefore, I get 9 pi on 6. Or rather, you can write down 3 pi on 2 if you simplify on the next step. Obviously, this is again 2 pi on 6 that is 13 pi on 6. We can simplify a bit further. 3 pi on 2, comma 13 pi on 6. So they are the solutions for our original equation, which said sine x minus root 3 cos x equals -1. Okay, ladies and gents, I thought you got through these questions. I'm going to do another video lesson for the next section. Until then, enjoy. Bye for now. Thank you.